As countries and communities strive to reduce greenhouse gas emissions from deforestation, it's important to have the right tools. Parties of the United Nations Framework Convention on Climate Change decided recently that countries need national forest monitoring systems that are transparent, consistent over time, and suitable for measuring anthropogenic emissions from land use change. To help countries achieve this goal, the Food and Agriculture Organization of the United Nations launched the Open Forests Initiative. Open Forests is a set of free and open source software tools that facilitate flexible and efficient forest monitoring. Collect Earth is free, open source and user-friendly. It facilitates the assessment of deforestation and other forms of land use change. Monitoring land use enables countries to quantify their impact on climate change in this sector. It uses Google Earth's interface and the satellite imagery hosted within it to view plots of land. Google Earth features current and historic high-resolution imagery for many parts of the world. Land use classification systems can vary greatly by country. Collect Earth is flexible and can be customised to suit different environments and different environmental guidelines. This version of Collect Earth has been customised for a drylands assessment of Southern Africa. Collect Earth pulls a HTML-based form into Google Earth, where users can enter and save their observations of the land use of each plot. For the drylands assessment, the tabs above represent different forms that aim to collect information according to specific guidelines. For the IPCC, there are 6 consistent land use categories: forest, cropland, grassland, settlement, other land, and wetland. This plot falls into cropland. The data collection forms for all of the land use categories include confidence options that allow users to indicate their level of certainty with their selections. The land use conversion category indicates the dynamics of the plot. To determine the land use conversion category, you need historical satellite imagery, dates of imagery acquisition, and a reference period. To view the historical imagery within Google Earth, click the clock icon. This plot contains imagery from 2003 to 2013. In November 2006, the entire plot was grassland. In 2010, 4 years later, the entire plot had been converted to cropland. In 2013, the plot falls into cropland. The land use conversion category of this plot is grassland converted to cropland. However, the precise year of transition is not clear due to the lack of imagery between 2006 and 2010. For most plots, the high-resolution imagery within Google Earth is not comprehensive enough to determine the year of conversion or the current land use. For these areas, high-resolution imagery within Bing Maps and Google Earth Engine can help interpret the medium-resolution imagery in Google Earth. Clicking anywhere within a plot launches new windows in your web browser with Bing Maps, Google Earth Engine, and Earth Engine Playground zoomed into the plot location. Bing Maps is provided by Microsoft. It contains high-resolution imagery from Digital Globe. Its geographical and temporal coverage overlaps with Google Earth, but it also covers some areas where high-resolution imagery is not available in other applications. On Google Earth Engine Playground, the user has access to different vegetation indices. These indices are shown in time series charts and can facilitate the identification of seasonality in vegetation cover. Google Earth Engine contains over 40 years of continuous Earth observation data gathered by the United States Geological Survey and its Landsat program. Although Landsat imagery is medium spatial resolution, its global geographic coverage and frequent acquisition dates make this dataset extremely valuable for land use monitoring. Patterns in the landscape can help identify common features between high-resolution imagery and medium-resolution imagery. Adjusting the visualization of Landsat imagery can also make patterns in vegetation and land use change stand out. Using this Landsat 7 Greenest Pixel composite, we can access old imagery for this area and confirm that this plot was converted from grassland to cropland in 2009. The same process can be used to determine the year of deforestation. Collect Earth, together with Google Earth, Bing Maps and Google Earth Engine, provide an easy and systematic way to review satellite imagery and assess land use. Saiku Analytics is embedded in Collect Earth. Saiku is a free tool that allows users to explore complex data sources and visualize the data in a user-friendly yet robust way. This example illustrates a data test on a land use and land use change assessment undertaken by the Forest Authority of the Government of Papua New Guinea. Using an interactive drag and drop interface, the user can quickly access important information and choose how to visualise it. This table displays a land use conversion matrix. We can see from the matrix that 37.6 million hectares of forest land remained as forest, while almost 1.7 million hectares of what was initially forest land were converted to cropland. Using the Saiku Zoom function, the user can filter the data related to this land use conversion and easily visualise additional information. This example illustrates the agricultural systems that are most commonly used in the country. In this instance, shifting agriculture represents the main direct driver of land use conversion, followed by palm oil. When adding information on provinces of the country, the table becomes more complex, as it contains additional layers of information. Saiku overcomes this challenge by allowing the user to visualise the data using interactive charts. Here, we can see that in most provinces, shifting agriculture represents the main direct driver of land use conversion, while land use conversion driven by palm oil is concentrated primarily in the province of West New Britain. Collect Earth is a new open source tool which enables the user to undertake traditional sampling assessment through innovative visual interpretation techniques based on a wide variety of data and information. This enables an accurate assessment of the land and its dynamics in which the user is interested. It can assist governments, communities and others to make well-informed decisions on sustainable forestry and land management.